Today, we are going to be looking at how do we calculate limiting reagent and theoretical yield. So, limiting reagent is basically just what reactant are we going to run out of first? Because in a chemical reaction like this one that you can see on your screen, this one, okay, one of these reagents, either phosphorus or oxygen, may run out first. We may not have enough. So when that runs out, the reaction is going to have to stop because we don't have any more of one of the key ingredients to make this product. So whatever runs out first, we call that the limiting reagent. So let's look at how we calculate that. So it says determine the theoretical yield. We're going to talk about theoretical yield in just a minute of P2O5 formed if 25 grams of phosphorus and 50 grams of O2 were reacted according to the following equation. Now, I can see my equation doesn't have any coefficients, so it's probably balanced. So I have to balance this equation first. Now, if you don't know how to balance an equation, I would encourage you to watch my video on how to balance chemical equations. For this part, I'm just going to save us a little bit of time. The balanced equation is 4, 5. So I want to find the limiting reagent first because that's how I figure out my theoretical yield. So to do that, I'm going to convert both 25 grams of phosphorus and 50 grams of O2 into the same product, okay, into moles of that same product. And that will allow me to compare these amounts in the same unit, and so I can more easily identify which one is limited. So I'm going to take 25 grams of phosphorus, and I'm going to convert this into moles of phosphorus. So 1 mole of phosphorus is going to be 30.97 grams of phosphorus. That's the molar mass from the periodic table. Then I'm going to use the mole ratio. So from my equation, 4 moles of phosphorus will form 2 moles of P2O5. Okay. Cancel my units. I've got 2 over 4 right here, so I can reduce this to 1 over 2. And now that I'm in moles of my product, I'm going to just plug this into a calculator and solve it. I got 0.40 moles P2O5. Okay. Now I'm going to do the same calculation, but I'm going to start from 50 grams of O2. So convert it into moles. That's 32.00 grams of O2. Again, that's the molar mass. Cancel my units. Use the mole rate. 2 moles P2O5 will be formed from 5 moles of O2. Cancel my units. Now I can also do some reducing here. Okay, 50 and 5 can reduce to 1 and 10. 2 and 32 that can reduce to 1 and 16. So my answer is really 10 divided by 16. That's 0.63 moles P2O5. Now that these are in the same unit, moles of P2O5, I can clearly see that phosphorus is limiting. So I'm going to leave a little mark. Okay. And because phosphorus is limiting, the one that is not limiting is said to be in excess. That just means we have more than we need. Okay. Now I need the theoretical yield. So I'm going to take the moles produced from the limiting reagent, because that's the max we can produce with what we were given, and I'm going to convert this into grams. Okay? Theoretical yields are almost always reported in grams. So I'm going to put 1 mole P2O5 on the bottom, and on the top, I'm going to put grams of P2O5. So to go from moles to grams, I need the molar mass. Phosphorus, 30.97 times 2, that's 61.94. Oxygen, 16.00 times 5, that's just 80. Add those together and you get 141.94. 1. Okay. So I'm going to take the amount of moles produced by limiting reagent, that's uh, 0.43, or I'm sorry, 40, and I'm going to multiply that by the molar mass of the product, 141.94. What I get is 57.20 grams P2O5. This amount is what's called my theoretical yield. Theoretical yield just means what is the most that you can produce from these two reactants in these amounts if everything goes perfectly. Okay? So my limiting reagent is what determines how much I can make. So for this question, the answer is theoretical yield is 57.20 grams of P2O5.